Let's wait for a while. Hey guys, it's Going here, and today I have my friend Cams with me. So, okay. So Cams has asked us to answer a problem related to her basic calculus subject, which is the application of derivatives in motion bodies. Yes. So, without any further ado, let's start. Okay, so Cams asked us to solve this problem. So our problem is Chelsea is pouring water in a glass in the form of an inverted cone, having an altitude of 16 centimeters and a radius of 4 centimeters. The water is flowing into the glass at the rate of 2 cubic centimeters per second. How fast is the water rising when the water is 5 centimeters deep? So, to begin, we will let T be the time elapsed since water started to flow into the glass. Time elapsed. Then we will let H meters, or H, be the height of the water level at T minutes. Height of water at T. Then R be the radius of the surface of the water, surface at time T, or at T. Then V, at V be the volume of the cone. Now, the formula of finding the volume of a cone is equals to V is equals to 1/3 pi r squared h. Now V, we all know that V, R, and H are all functions of T because water is flowing into the tank at the rate of 2 cubic centimeters per second. So 2 cubic centimeters per second is our dV over dt. So let's write that here. Now, what we wish to find is our dH over dt, and that is our unknown. When H is equals to 5. So to express R in terms of H, we will go back to our past lessons about similar triangles. So, Camille, why similar triangles? So, if you look closely into the figure, we can actually form two perfect right triangles in the figure. So, let's do that right now so that you guys can see. That is our first triangle. So 4 centimeters, and this is our 16 centimeters. Now, for the second triangle, which is actually our unknown, we will have... So actually, we don't have the values for this, so we're just gonna name them R and H. So we all know in similar triangles, the bigger triangle is equal. The smaller triangle is proportional or equal to with its R over H. So we will do that here. So our R, first R is. So since our R is unknown for the second triangle, we'll have R over H, just like so. And then we will have 4 here since they are proportional and 16 here. So we're not done yet. We need to express R in terms of H by transferring H onto the other side of the formula. Okay, so this formula of R will now be substituted to the R here. So let's do that. Now, V is equals to 1 over 48 pi h cubed. So from now on, we will be using this formula to solve the problem. So from this formula, the next step is, so we will derive both sides of this equation with respect to t. So this will become dv over dt is equals to 1 over 16 h squared times dh over dt. So how did we come up with this problem? This equation rather. So all we have to do is multiply 1 over 48 times 3, which will become 3 over 48. If you simplify it further, it will become 1 over 16, hence this one. And then the square, after that, you will subtract 1 from the power. So 3 minus 1 is equals to 2, hence the 2 over here, and dh over dt. So if you go back to the given, we see that we have a value for dv over dt, which is 2. So we will substitute that here. If you look closely, we can now solve our problem. So we can now solve for dh over dt and hence solving our problem. So the result for that one is dh over dt is equals to 32 over 25 pi. I'm sorry, h.
Beep.
H pa. I'm sorry. 32 over h squared pi, or pi h squared. Now that we have this formula, we can say that dH over dt, if h is equals to 5, is equals to 32. 5 squared pi is equals to 32 over 25 pi. Therefore, the water level is rising at the rate of 32 over 25 pi centimeters per second when the water is 5 centimeters deep. That's how you solve the problem that CAMS gave it to us. CAMS? So that's it, you guys. That's everything you need to know. Now, if you have any questions, just comment down below. And if you like this video, please don't be afraid to click share and like this video for the sole purpose of me passing in my basic calculus for this is our project. So thank you very much. Have a nice day. See you again next time.